Physicists. So I'm going to pick up a little bit from where we left off yesterday. So at the very end of class yesterday, we were looking at this example of Rolf pushing his piano across the room, moving at a constant velocity, and right before the bell rang, we decided that we had to have a second force acting in the x direction. So just kind of to remind you of where we were, we said that the piano was moving at a constant velocity, and because it was a constant velocity, the object was not accelerating in the y direction. And as a result of that, we needed to have some force that was acting against the applied force, something that was causing it to not accelerate. We called that the force of friction, and then you had to leave. So I want to talk to you just a little bit about what friction it is itself. So every two surfaces, when they try to move past one another, struggle unless they are super, super smooth. And even in that case, friction really technically does exist. So I want to take a look at what those surfaces are and how they kind of interact with each other. So I want you to imagine that maybe this is a box or a piano or something like that. And this maybe is like a floor or a desk or something to that effect. Okay. So as those two surfaces just sit next to each other, no big deal. But as soon as they start to move, you'll notice that those surfaces, even though they look flat, aren't really flat. They have got little bumps and crags in them. And as they try and push past one another, those bumps stick a little bit. And that's what causes this thing that we call friction. So friction is really just a force that is an interaction between two surfaces, and it always acts parallel to the surfaces. So as the box tries to move this way, or it could look like the floor is moving this way, those bumps cause things to make it a little bit harder to move. Okay, so if we take a look in our force inventory, we're going to add the force of friction as the next force on our list. So go ahead and pull that piece of paper out. We're going to write down some information here. So the next force that we're going to write is the force of friction, FF. And when we talk about the object pulling or pushing, or the thing that's causing this force, because remember the forces are interactions between two objects, the box or the bowling ball or the frog or the whatever, okay, is interacting with a surface. The surface is necessary for that frictional force, okay? So that could be the floor or the table or the chair or whatever. You may notice that we have surface here and we have surface here. Indeed, the surface actually can cause more than one type of force. So the normal force we said was perpendicular. The surface force in friction is always acting parallel to the surface. Okay, so if we were going to draw a force diagram with that force, I drew my surface there, and so here's my object, and maybe it's being pulled to the right. If it's being pulled to the right, then the frictional force is going to act to the left, and you'll notice that that line, that arrow, that vector is parallel to the surface. So it's going to be the force of the surface on the object, and again, it's parallel, okay? One other thing to note about the direction is that not only is it parallel to the surface, but another piece is that it is always opposing the motion. Okay, so it's going to want to slow things down or stop things or prevent things from moving. So you can kind of keep track of what direction that force is going based on what else is going on in the story. I just said it's going to slow things down. Slowing things down is changing the velocity. So indeed, it is able to cause acceleration. Okay, generally to slow things down, or like I said, to prevent things from moving. Once we get into the numbers next trimester, we'll get some more details with that.